Hello everyone, so in this video let us talk about a problem from LEETCODE. It's a hard problem. The problem name is minimum cost to cut a stick. Okay, so given a wooden stick of n length, as you can see, the stick is labeled from 0 till n. For example, a stick of length 6 is labeled from 0, 1, 2, 3 and 6 on. So given an integer array cuts, where cut of I denotes the position where you want to perform a cut on this particular stick. Now you should perform the cut in the order. You can change the order in any wish you can. So you are given some order. So the cut position. So you can cut the stick at the position 1, 3, 4 and 5. Okay. So you are given these cut position and you can only cut the stick at this given point. But you can do this cutting in any order you want. So as you can see that in the example, that is, let's say that you're given a stick of length 7. As you can see, and you have these cuts available to you. So let's say that you do a cut at 3 first. So if you do a cut at 3, it becomes this and this stick. Then you do a cut, let's say at 5, so it will become like this. Then you do a cut at 1, so it becomes like this. Then you do a cut at 4, and then it becomes like this. So you can also reorder these cuts. So maybe you can first do the first like this 1 position cut, then the 3 position cut, then the 4 position cut, and then the 5 position cut. So you can do these cuts in whichever order you want. But the main problem actually comes down in this last paragraph. The cost of one cut is equal to the length of the stick to be cut. Okay, the total cost is the sum of the cost of all the cuts. So let's say that if you do a cut in this particular stick, so let us take the example only so that it becomes more clear. 1 2 7 3 5 1 4. So this is a stick. Okay, so it's 0 1 2 3 4 5 6 7. Okay, let us move this out. This is the stick, and you can do a cut at position 3 5 and 4 3 5 1 4. Okay, now if you do the cut at the position 3 like this, you are doing the cut in the whole stick, which is of length 7. Okay, then you do a cut, let's say a position 1. So now you have this stick and this stick. If you do a cut at position 1, you are doing a cut in the stick of length, let's say 1 2 3. So in a stick of length 3, so 7 plus 3. But let's say that if you do a cut in the stick that is 5, that is here, so it is of length 4, so 7 plus 4. So the order in which you do the cuts actually depends upon at which stick length you are doing the cut. So you have to return the minimum cost of doing this cut, so that the minimum cost occurs when you do these cuts. Okay, so the simplest way to do this problem is you have these cuts. Okay, so at every position, let's say that you have this stick, and let's say that the cut positions are so 0 1 2 3 4 5 6 and 7. Now if you can do the cut at 3, if you do this cut, it will divide this stick into 2 halves, from this to this and this to this. So first you have to understand that what all parameters you are playing with. You are playing with, if you are cutting at any point, you have divided into 2 ranges. So it's L and R. Similarly, it is at L1 R1, L2 R2. So what you can directly understand from here is that you have different ranges, L1 and R2. So you can take these ranges as what is the profit, or like what is the minimum total sum I can get to divide this stick from range L1 to R1. I hope you get the point. So L1 and R1 is actually is on this stick, like the total number of cut positions. I hope you get the point. So I'll tell you with example so that it will become more clear to you. But what I'm trying to do here is, so you have these, let's say 4 positions. Now what you will do is that you try to cut at every position. So let's say that you try to cut at 3. If you cut at 3, you have this stick as well as this stick, and on the left side of the stick, like on this stick and this stick, you can easily find out, okay, if I'm doing a cut at this position, what is the profit I'm getting, the total length of the stick that I'm cutting, that is also fine. How I can get that? I will start from the very starting range, that is from 0 till the last entry, that is n minus 1. Okay. Now if I'm doing a cut at this particular position, what I'm trying to do is that I now have the stick from this position to this position and this position to this position, and the cuts, that the number of cuts I can do, I can also divide them from this section to this section, because I have done and taken this cut. So now I can do a recursive call on this stick. On this stick, what is the minimum cost I can get with the stick I have is this, and the like cuts I can do is these cuts. Also, as you can see that this is not sorted, so you have to also sort this out. So if you sort this out, you have to also first sort it out so that we can move. You can easily divide them out. So you have to sort this out to 1, 3, 4, 5. So let's say that if you are dividing this at the third index, like this third position, then what you can do, you have two sticks left, that is this and this stick. So this, now you do a recursive call on this L2R and this L2R, and because you have taken this, so now on this L, at what positions you can do a cut? You can do a cut on these positions that I have on the left hand side of the cut you have taken, and on the right hand stick you can do the cut on these positions, that is 4 and 5. So you can just take two variables L and R. Similarly, you have to take variables over this array also, like at what positions you are doing the cut, and you can easily manipulate those terms to like write the recursive function, and then over that you have to just write memorization. So I'll directly move on to the code part so that it will be more clear to you, but that's the overall idea, and it will become more clear when you go through the example. So I have taken a DP table. This is L2R. L2R is, so L2R, I am actually talking about what is the number of cuts I can get on the left hand side. So if I've taken the ith cut, how many cuts I can do on the stick on the left hand side, or how many cuts I can do on the right hand sides. Okay, so these are the number of cuts I can do according to the constraints also, because this tend to have 6, so I cannot do it over this n, but I can do over the number of cuts I have. Like I can do very small cuts, so I can do 100 cuts, so 101, 101. Okay, now what I have like sorted out this array which I've told you, then call this solve function. Now what are the parameters I'm passing? I'm passing 0, n. By 0 and n, I means like what is the stick length. So stick length, so the initial stick length is that what is this range L2R. So this is like the range is equal to 0, and this is R is equal to like n minus 1. So the total length is n, sorry, the total length of the stick, so 0 n. This is a cuts array, at what positions I do the cut, and this is 0 and cuts n minus 1 is, let's say that at what positions I am on this cut array, because I have to divide this cut array as well as this stick. So this cut array is also from 0 till n minus 1, the index is from 0 to n minus 1. So n is the cut size. Okay, now what I'm trying to do here is that this solve function is called. Now the range, what is the base case? This is the range L and R. Okay, if they cross, like if they like if they overlap each other, like if L becomes some like left becomes greater than right. Okay, so this is the left and right. So what you can directly understand is the DP table is also caring about this left and right are iterating over this array. Okay, not the stick. I am not talking about the stick. I'm talking about the cuts in the array itself. So if the number of cuts I have, if the position I want to cut, because I have cut on the ith point, now I have two different ranges. If L becomes greater than R, I'll return 0. If the state already exists, I'll return that state. Now I have to minimize the total cost, so increase, like make the cost is to greater value. Now I have a range from left to right, so I'll iterate over every cut position over this range. Now I have two options, what you can see, like on the left cost and the right cost, because if I'm doing a cut at the ith position, what I'll have to do, I have to recursively call the left side, right side, and because I've done a cut in the ith point, what is the total cost I have incurred while doing a cut on the ith point. So if I do, what you can say on the left cost of the stick is, what you can say, if I have done the ith cut at this position, okay, what you can at least say, this is L, the left cut stick position. Okay, so what you can directly see that the total stick now comes down from 0 till this position. Okay, so from 0, so start stick position and the ith position which I have cut. So that now the new stick length. So the first two parameters are defining out the stick So the stick start from 0th and the nth index. So now because I've done the ith cut at the ith position, the stick now becomes from the start index, that the start position, to cut a 5. This is the cuts array. And now because I have done this cut at the ith position, the number of cuts I can do on the left hand side is from 0th index, that is the left, to I minus 1, because the ith cut I have done. So the number of cuts I have left is from like the start to like I minus 1. Similarly on the right, cost is equal to similarly from cut of I till like the stick of end length, then the cuts, and I plus 1 because I've done the ith cut, so I plus 1 cuts to the right. And the cost, the total cost comes out to be the left cost, right cost, plus the cost of cutting at the ith point. That is the length of the stick. So length of the string is the n. So this is the stick which I'm iterating over. That is, the stick is start stick and the end stick. So like subtract out these two will give you the stick length on which you are doing the ith cut. So this is the total cost you will incur, and you have to just minimize it over all the cut positions you can do over this particular range you're talking about. So I've done a for loop over the range. So at every position inside this range, you have some cut positions you can do. Okay, and if you can do a cut position at that particular instance, then you can do a cut and find out what is the total cost you can incur, and then you have to like just minimize over the cost and just store that cost in the DB table before returning out. That's the overall solution part for this problem. There are a lot of different problems as well which are similar to that. If you understand this logic, other problems also become very easy, and I will be also posting out videos on those solutions also. So burst balloon problem, you can check out that problem and understand and try to write in the code for that. I will be posting out the video for that also in some later half, but that is also somewhat similar to this problem. So if you understand this problem, you will only totally understand that problem as well. So that's the overall code and logical part for this video. Thank you for this video till the end. I will see you next one. Till I keep coding, and bye.